back, everyone. Today, we're diving into one of the most intriguing frontiers of neuroscience and human experience. What happens to the brain under the influence of psychedelics? Psychedelics, substances like LSD, psilocybin, the active ingredient in magic mushrooms, and DMT, have captured public imagination for decades, not only because of their profound effects on perception and mood, but also due to the deep questions they raise about consciousness and the nature of the mind. In recent years, renewed scientific interest in these compounds has led to groundbreaking research into their effects on brain function, and today we're going to explore those fascinating findings. When you take a psychedelic, the first thing that happens is that the substance quickly crosses the blood-brain barrier. Once in the brain, these compounds interact primarily with serotonin receptors, particularly the 5-HT2A receptor. This receptor plays a crucial role in modulating mood, perception, and cognition. By binding to these receptors, psychedelics essentially rewire the brain's communication pathways for a period of time, leading to altered states of consciousness that can range from vivid hallucinations to a profound sense of unity with the universe. One of the most consistent findings in psychedelic research is that these substances reduce the activity in what's known as the default mode network, or DMN. The DMN is a collection of interconnected brain regions that become highly active when we are engaged in self-referential thought, essentially when we're daydreaming, ruminating, or thinking about ourselves. Under the influence of psychedelics, the DMN's activity decreases, which can lead to a dissolution of the usual boundaries between self and world. This reduction in DMN activity is often associated with experiences of ego dissolution, where individuals report a loss of the sense of a separate self and a feeling of interconnectedness with all of existence. For many, this experience is both liberating and transformative, offering a new perspective on life and one's place in the world. At the same time, research shows that psychedelics increase global connectivity in the brain. Normally, the brain's regions are relatively compartmentalized, with different areas handling specific tasks. However, when someone is under the influence of a psychedelic, these boundaries start to blur. Brain imaging studies have revealed that networks which typically operate independently begin to communicate with each other more than usual. This increased connectivity is thought to be responsible for the rich, complex visual and sensory experiences reported during a psychedelic trip. It might also help explain why many users experience a surge in creativity and a newfound ability to see problems from multiple angles. In some ways, it's as if the brain's internal wiring is being temporarily rearranged, allowing for fresh connections and novel insights. The profound changes in connectivity also have implications for how we process emotions. Under psychedelics, the enhanced communication between brain regions can lead to a more fluid exchange of emotional information. This might help explain why some therapeutic studies have shown that psychedelics can reduce symptoms of depression and anxiety. By resetting certain neural circuits and breaking down rigid patterns of thought, these substances can help individuals process traumatic memories or break free from destructive habits. The experience isn't simply about experiencing intense emotions, though. It's also about gaining clarity and perspective. Many report that after a psychedelic experience, they find it easier to understand their own emotional landscape, sometimes even feeling more compassionate toward themselves and others. Of course, while the immediate effects of psychedelics can be profound and sometimes even life-changing, it's important to note that these substances are not without risks. The altered state of consciousness can be disorienting or overwhelming, especially if someone isn't prepared for the experience. Bad trips, episodes marked by intense fear, anxiety, or paranoia, are a well-documented risk. However, these negative experiences are often linked to set and setting, meaning the individual's mindset and the environment in which the substance is taken play a huge role in determining the outcome. That's why modern research emphasizes the importance of a supportive, controlled setting when using psychedelics, particularly in therapeutic contexts. Beyond the acute effects, there is growing evidence that psychedelics may have long-lasting impacts on the brain. Some studies suggest that even a single, well-guided psychedelic experience can lead to enduring changes in personality, increased openness, and a greater appreciation for life. These findings have sparked a lot of excitement in the fields of psychiatry and psychotherapy, where researchers are exploring psychedelics as potential treatments for conditions like post-traumatic stress disorder, addiction, and major depressive disorder. The idea is that by disrupting entrenched neural patterns, psychedelics offer a window of opportunity during which individuals can reframe their experiences and adopt healthier ways of thinking. It's also worth mentioning that these substances have a storied history in many cultures. Indigenous peoples around the world have used naturally occurring psychedelics in religious and healing ceremonies for centuries, viewing the altered states they induce as sacred and transformative. This traditional use underscores a fundamental truth. Psychedelics tap into aspects of human consciousness that have always been part of our experience, even if modern society often treats them as fringe or dangerous. In recent years, as research has begun to validate some of these ancient insights, we're seeing a growing interest in integrating traditional wisdom with modern scientific understanding. From a neurochemical standpoint, the cascade of events triggered by psychedelics goes beyond just serotonin receptor activation. There's also evidence that these substances promote neuroplasticity, the brain's ability to reorganize itself by forming new neural connections. Increased neuroplasticity means that the brain can adapt and rewire more easily, potentially offering a pathway to recovery for those struggling with entrenched mental health issues. This neuroplasticity might be one of the reasons why some individuals report lasting improvements in mood and cognition after a controlled psychedelic experience. As we consider the science of psychedelics, it's essential to view these substances not as magic pills, but as powerful tools that interact with our brain in complex ways. The promise of psychedelics lies in their ability to open new avenues for understanding the mind and, ultimately, to help us heal from psychological wounds. However, their power also necessitates careful, respectful handling, both in research and in any therapeutic use. In summary, what happens to the brain on psychedelics is a multifaceted process. These substances disrupt the usual neural activity by acting on serotonin receptors, dampening the default mode network, and increasing global connectivity across brain regions. This leads to altered perceptions, emotional breakthroughs, and a temporary dissolution of the self. While the immediate experience can be both exhilarating and challenging, the long-term potential for therapeutic benefit is what excites scientists and clinicians alike. Psychedelics offer us a unique window into the workings of our own minds, challenging our assumptions about consciousness and opening the door to innovative treatments for mental health conditions. Thanks for joining me on this deep dive into the science of psychedelics and their impact on the brain. Whether you're a curious mind or someone seeking answers for personal challenges, the study of these substances reminds us that the human brain is an endlessly fascinating frontier. Until next time, stay curious, keep questioning, and remember that exploring the mysteries of the mind is a journey worth taking.